So we've got an equation, y equals negative x squared plus 4. Algebraically, to find the inverse, switch x and y. And then solve for y. So if I switch x and y, I would get x equals negative y squared plus 4. If I want to solve for y, I want to get the y squared by itself. A couple of ways you can do this. You could subtract the 4. How do you get rid of a negative? Right? I could subtract 4 on both sides. And then I could divide by a negative 1. Can you see? Or times by a negative 1. Either would work. If I did that, the x would become negative, the 4 would become positive. Y squared. Then, how do I get rid of a squared? Square root it, and I have to remember, when you square root both sides, plus or minus the square root of negative x plus 4. Okay? Do you remember how to graph from this year and from grade 11 pre-calculus? If I was graphing from this year, I would say, do I know what a parabola looks like, just an x squared graph? What is the negative out in front? Vertical reflection. What is the plus 4? Vertical translation. So using this year's math, here's part B, I could graph by x squared, flipped over, moved up 4, 1, 2, 3, 4. See how I went over 1, over 1, down 3? And there I have my graph of the original. Then we're going to graph this. It's the inverse. Two ways you can graph the inverse. You can use your transformations and graph this. However, it is always the easiest when graphing the inverse to think about all I need to do is take my coordinates and switch them. So what's going to happen to 0, 4? It's going to become 4, 0. What's going to happen to 1, 3? 3, 1. And negative 1, 3. 3, negative 1. Negative 2, 0. Oops. 0, negative 2. And 2, 0. 0, 2. This is why you almost need to have different colors. Question? Yeah. So now that I have that, can you see that you get a sideways parabola? All I did was I switched the x and the y coordinates. I imagined, this is where, can you see, if you drew the dotted line here, does it flip over okay for you? Okay. Much more difficult would be, but not impossible, using your transformations. If you used your transformations, the plus or minus actually separates this into two different equations. One equation with the plus, and one equation with the minus. Okay? If we walk through this, What does the negative inside the square root do? Vertical or horizontal? Horizontal, because it's inside. This would be a horizontal reflection. The 4, it makes sense that it's a translation. Which way should it translate? Right. But it went right. Why? Because of the special note that you were supposed to put a reminder at your phone at 8 p.m. every night. This isn't in factored form. So this is why I would say this would be harder. If you tried to graph this, can you see yourself forgetting that you would have to write it like this? And it's 4 to the right, not 4 to the left. Think about your regular square root graph. If I did a horizontal reflection, it would normally like this. Now it goes like this. And move 4 to the right. This one is the top square root. This one with the double negative is the bottom square root. And we need both square roots together to make the sideways parabola. All right. Is the inverse a function? Is the blue one a function? Does it pass the vertical line test? No. So part C, it is not a function. Okay. Questions 5 and 6. Now, at the bottom of page 239, the bottom of page 239, it has the following question. There. Bottom of page 239, it has this question. When can you tell that the inverse of the function will also be a function? No problem. Okay? So, for example, we took a parabola, and when we flipped it, it became a sideways parabola, and this one does not pass the vertical line test. So the question is there a way that you could tell on the original graph right away? I look at the parabola and go, yes, I know the inverse won't be a function. But if I looked at the x cubed graph, I could say, yes, the inverse will be a function even before I graph it. By the way, if you flip this one around, it would look like that. And it's a function. The vertical line, no matter where I put this vertical line, hits the graph only once. So now, if I draw a random graph, how about this one? Will the inverse be a function? No. How about this one? Yes. What is the trick to being able to tell looking on the original one? The trick is very similar to the vertical line test. We can use the horizontal line test. If the original function passes the horizontal line test, then the inverse will also be a function.